Welcome to today's great math adventure. Today we are hiking along the Blue Ridge Parkway. We're currently about 6,000 feet above sea level right now. You can see the beautiful view behind me. Let's go ahead and jump into the math video. Welcome to lesson 3-3. In this lesson we are going to add another method to solve systems of equations into our tool belt. So we have already dealt with graphing, and we've shown how to use graphing to help us to solve systems of equations. Now, not every time will a problem be easy to graph. Sometimes we may end up with large y-intercepts or fractional y-intercepts, or slopes that are not necessarily the prettiest to work with, or they are going to cross in between our lattice points, where it's going to be hard to tell the exact values. Luckily, we have some different algebraic methods that we can use, and we're going to look at one of those today, called the substitution method. And the substitution method is going to rely heavily on the substitution property of equality, which says that if we know that two values are equal, then we can replace them with each other in any equation or expression. And so we're going to use that to our advantage in solving some of these equations. So the first example we're going to start out with is going to be example 1, where we have two equations that both have the exact same variable isolated. You'll notice on both of these equations that they are solved for y. We have y equals negative x plus 3, and we have y equals x plus 5. So what I'm going to do is I'm going to replace this y with something that I know y is equal to. And when I look down into the second equation, it's going to tell me that y is equal to x plus 5. So all I'm going to do is I'm going to replace that first x with what y is equal to, the x plus 5. So I'm going to rewrite this, and instead of putting the y at the beginning here, I'm going to put x plus 5, and then I'm going to put the rest of my equation from over here, negative x plus 3. So now I have an equation where instead of having two different variables, I only have one variable. They are both x's. And we know how to solve these equations from thinking back to solving multi-step equations. So the first thing I want to do is to go ahead and get both variables on the same side. So I'm going to keep things positive and add an x to both sides. That will give me a 2x plus 5 is equal to 3. Now to continue solving for x, I would subtract 5 from both sides to get the 2x by itself. And that will give me 2x is equal to negative 2. And then I'm going to use the division property of equality to get rid of the 2 that's in front of the x, and get that x is equal to negative 1. So that's just like when we were solving just a singular equation that had multi-steps. However, there is one thing that we're going to have to do to take things further. Remember, we've talked about how the solutions to a system of equations are an ordered pair. However, we only have an x value. So what we need to do is to take this x value and figure out y value that goes with it. And to do that, I'm going to take it and I'm going to plug it into either of my original two equations. It doesn't matter which one you plug it into. I would just encourage you to plug it into the one that looks the easiest. To me, I don't want to have to deal with a negative in front of my x. So I'm going to take this x equals negative 1, and I'm going to plug it in where x is in this equation. So I'm going to do y equals, I'm going to replace the x with negative 1, and then finish out the equation with a plus 5. So negative 1 plus 5 is going to give me 4, so that gives me a y value of 4. Now when I put that together with my x value, it gives me the ordered pair, negative 1, 4. And that will be my solution. And again, I can check these by plugging them in. Now I already know that negative 1, when I plug it into this equation, will give me 4, so that is pretty much already checked. But it also has to make the top equation true as well. So now just to check it, I'm going to plug those values into the first equation. 4 would equal a negative, and then I plug in my negative 1, plus 3. So that would give me 4 equals a positive 1 plus 3, and 4 equals 4. So I have checked this answer, and I can see that that ordered pair actually does make both of these statements true. Now, in the coming videos, we'll look at a couple ways that you can deal with this that might be a little bit trickier, where you don't necessarily have the y solved, but we'll show you how to take care of that as well. Alright, there are a couple you try videos, or you try problems on this video, so go ahead and pause now. Make sure you give the you tries an attempt, and to check those answers on the solution guide. And then when you're done and you have made sure that you have the answers correct, go ahead on to video 2. We'll see you there.